it a little bit more towards the other door. There we go, beautiful.
Oh.
Grab the book behind it.
There we go.
Okay. Okay, let's talk about 3.8. Oh.
That's. Whoa.
Okay, using inverse matrices to solve linear systems, okay? What does inverse mean? The opposite of something, right? So we have done inverse equations before where you switch x and y, resolve for y, and you have your inverse equation, yes? Okay, so this time we're going to do inverse equations with matrices. Now, it's pretty easy once you get the hang of it. Once again though, with matrices, everything just takes some time, okay? The n by n identity matrix, okay? An identity matrix is a matrix with ones on the main diagonal and zeros everywhere else, okay? So in a 2 by 2, your identity matrix goes 1, 0, 0, 1. In a 3 by 3, an identity matrix has ones down the middle and then zeros everywhere else. Okay, we're only going to work with 2 by 2s and 3 by 3s. And we're going to talk about what this means. When you are finding the inverse matrix of something, if you multiply the inverse matrix by the original matrix, you will get an identity matrix. That's how you know you did it right.
Wait, say that again.
When you find the inverse matrix of something, when you re-multiply it to the original matrix, if you get an identity matrix, that's how you know you did it right. Okay? They produce only ones and zeros. Two n by n matrices, A and B, are inverses of each other if their product in both orders, meaning it doesn't matter which way I multiply them, I can actually switch these ones, okay? Create an identity matrix. Meaning, if A times B equals the identity, and B times A equals the identity, then you have an inverse of each other. Okay?
You have to multiply A times B and B times A to find out if you have an identity.
Not necessarily, because if you do it one way, it will work the other way. Okay? So, inverse of a 2 by 2 matrix. The inverse, here's how you find it. Okay, to find the inverse, you have A, B, C, D, right? Okay? What you do is you take 1 over, what does this A mean in here?
Matrix.
Starts with the D, it's what we've been doing.
Domain. Domino. Domain.
Determinant, the determinant.
Inner domain.
So you take the inverse matrix, okay, A to the negative 1, that stands for inverse, the inverse matrix of A, okay, equals 1 over the determinant. So what you have to do is figure out what the determinant is, and you have 1 over it, okay? That gives you a fraction. When you take that fraction and multiply it back into the matrix, you get your inverse matrix. Okay, we're gonna do it, because I think it's easier than looking at all these letters, personally. That's just my opinion. So look, they want us to find the inverse of this matrix, okay? And your matrix A says 3, 8, 2, 5, okay? To find the inverse of this, you have to do 1 over the determinant of A, okay? That's how you find the number to find the inverse, okay? So I'm going to set that up, and I'm going to say 1 over, how do I find the determinant of this? Yes, sort of crisscross. Yeah, I'm taking the diagonal. What's 3 times 5? Minus 2 times 8, which gives me what? So you have 1 over negative 1, which gives you negative 1, okay? I take this and I multiply it back into that matrix. So here's my matrix, okay? And all I do is multiply negative 1 in. When I do that, I get negative 3, negative 8, negative 2, negative 5, correct? Okay? That's what I get. Now, watch this. This is how I know it's the
absolute value.
It's not the absolute value. It stands for determinant when you're dealing with matrices. Determinant. Okay? So here is how you can double check. This is the inverse of that. Okay? The way I double check is I multiply them together. 3, 8, negative 2, or 3, 3, 8, 2, and 5, right? Times negative 3, negative 8, negative 2, and negative 5, okay? When I multiply them together, what's 3 times negative 3? Negative 9, plus 8 times negative 2. Wait a second. I go row times column, right?
Yes, but wait a minute.
That's not right. Wait a second. What am I doing? Find the inverse of negative 5. Oh, I remember. There is a trick to this. Time out. I lied to you. There is a trick to this. Okay. When you are finding the inverse, I have to do one other thing. Here's what happens. When you go to multiply it back to the original matrix, you're changing the order of the matrix. Okay? What happens is this. And I think it's on here. Look. What happens here? What do you, those switch places, and what happens to these?
Wait, no, these get.
They get negative. So this becomes negative 8, this becomes negative 2, and these two swap places. Then you multiply by what your determinant was under 1. So then I would get negative 5, I would get 8, I would get 2, and I would get negative 3. Okay? Now, when you multiply the original matrix, okay, by the inverse matrix, you should get ones on the diagonal and zeros everywhere else. So here's what happens. I have this times this, 3 times negative 5 is negative 15, plus 8 times 2, which is 16, okay? That spot. The next spot, I have this times this. 3 times 8 is 24, yeah? And then negative 24, plus negative 24. And then this spot down here is 2 times negative 5, which is negative 10, plus 5 times 2, which is, and then this spot is this times this, 2 times 8, which is 16, plus negative 15. So this comes out to be 1, 0, 0, 1. And that's how I know that that is my inverse function, because I get an identity matrix. So you have to find 1 over the determinant. Once you get the determinant, you multiply it by the A and D switching places, the B and C opposite of what they were. Okay, we're gonna try another one. Okay, this is a different tricky situation. So here's what it's asking. It says solve the matrix equation A times X equals B for the 2 by 2 matrix. Okay, they wanna know what matrix, that X represents a whole matrix, a 2 by 2 matrix. So what did you multiply the first one by to get that, to get the other equal sign? Okay, so what did I multiply this by to get the equal sign? How do you think we would work that? How do you think we would work that?
What, adding numbers?
If it said 3x equals 12, how would you work it? You would divide both sides by 3, right? This time, there's just a whole matrix there, okay? So here's how you work this system. If you wanna figure out what the matrix is that you multiply them by, you find the inverse matrix C and you multiply the answer side by the inverse, okay? Because then it's going to give you, it's going to work that problem backwards and give you the matrix that you originally had, okay? So you have to multiply by the inverse. To find the inverse, we have to do what? The determinant. So if I wanna find the inverse, okay, it is 1 over the determinant, okay? So I have 1 over, and I'm going to take the original matrix, matrix A, and I need to find the inverse of it. So I'm gonna take 1 over 2, negative 7, negative 1, and 4, right? This gives me 1 over 8 minus 7, which gives you 1 over 1, which is 1, okay? Now, when I go to multiply, what do I have to do? You have to do what with the matrix? I multiply by the determinant, but what do I have to do to the matrix to multiply?
Oh, A and D flip,
Yep,
and then B and C get,
so this is 7 and that's 1. So my new matrix comes out to 4, 7, 1, 2, correct? Okay, does that make sense? 4, 7, 1, 2. Now, here's what you do. This is how you show your work, okay? You are going to say 4, 7, 1, 2 times, and my original equation says 2, negative 7, negative 1, 4, x equals, okay? And I have to take my inverse and you put it first. You list it first, okay? 4, 7, 1, 2 times negative 21, 3, 12, and negative 2. You list it first, because remember, order matters, okay? When I multiply these, you know you're gonna get what?
7, 2, 1.
If this is the inverse of this, what do I always get out?
1 0.
1, 0, 0, 1, okay? So that's basically saying 1x, okay? Like there's just the 1. Now I have to come over here and solve. So this spot here is this row times this column. What's 4 times negative 21? Plus 7 times 12. 7 times 2 is 14, so 84, right?
Yeah.
Okay. And then this row times this column, what's 4 times 3?
12.
Plus 7 times negative 2. And then this row times this column, 1 times negative 21. Plus 2 times 12. And then this row times this column, 1 times 3. Plus 2 times negative 2. So my inverse comes out to, or my matrix came out to 0, negative 2, 3, and negative 1, correct? Okay, so that is what I multiplied my original matrix by. That's the matrix I multiplied it by to get that answer. So you have to use the inverse matrix to do it, okay? Does that make sense? Okay, you have to use the inverse matrix. Writing the system as a matrix equation, A times matrix X equals B. The matrix A is the coefficient matrix. X is the matrix of variables. Okay, so coefficients, and then you have variables, okay? B is the matrix of constants, okay? Because we're gonna give you equations. Find the inverse of matrix A, multiply each side of A, matrix A times X equals B by the inverse of A on the left side to find the solution X of the inverse of AB. Meaning, when I am given equations like this, how can I solve for X and Y is basically what it's saying, okay? The first equation is your what? What did it say the first equation is? Your coefficients. So, what are my coefficients? Yep,
23,
yep.
18.
No, that's a constant.
Oh,
2, negative 3,
1 and 4.
1 and 4. There's my first matrix. That's my matrix A. My second matrix was what?
X and Y.
Your X and Y. So I'm literally going to say X here, Y here. And it equals what? 19 and negative 7, my constants, okay? Because look, 2 by 2 times A, 2 by 1 gives me a 2 by 1, okay? So basically I'm solving for X and Y, okay? To solve for X and Y in this case, you have to use the inverse matrices, okay? Of the coefficients. So the inverse of A, so this is A, this was X, and this is B, okay? So so I need to find the inverse, so I have 1 over the determinant of A. 1 over 2, negative 3, 1, 4, right? 2 and 4 is 8, minus 1 and negative 3 is, so I get 1 over 11, right? 1/11?
Yeah.
Okay, you will get fractions on these. It's okay. Okay, now I take this and I multiply it by what? Yeah, how do I make it the inverse though? 4,
3,
3.
negative 1, 2.
So I end up getting 4 over 11. Let me tell you something. Do not, well, you can put them in decimals, but it's easier if you don't. Okay, because when you do inverse, it's easier if I don't put it in decimals. 3/11, I get negative 1/11, and I get 2/11. Okay? Now, what do I have to do with this? If I want to find x and y, what do I have to do with that? Multiply it by the constants. So I multiply it to this side because I'm trying to find this matrix, right? Just like we did over here, we were trying to find this matrix. This time we just put x and y inside of it. Okay? So I have 4/11, 3/11, negative 1/11, and 2/11, okay? And technically, if I were to write this the right way, I would have it multiplied by this. Okay, because this would cancel because it would go 1, 0, 0, 1. And then it would just have x and y here, yes? And then this side would say 4/11, 3/11, negative 1/11, 2/11, 19, and negative 7. So I take this row times this column. What's 4 times 19? 4 times 19, 76 divided by 11, okay? And you get 6.9. Plus, okay, because remember, it has to be added to this. 3 times negative 7 is what? And then divided by 11, and you get negative 1.9, okay? Now, this row times this column. Negative 1/11 times 19. Negative 19/11, right? So negative 1.7 basically plus
Wait, what was the decimal?
7.2,
Oh, it's
7.2,
0.01 off.
And then 2 times negative 7 is negative 14, so 14, negative 14 divided by 11 is negative 1.27 again, or it's the opposite, okay? So I combine those, okay, and this would give me x equals this top one, y equals the bottom, yes? So the top would be 5, right? Yeah, would be 5, and the bottom is going to be negative 3, 7, 8, 9, well, this would round to 1.3 actually, because it was 1.27. So that would give me negative 3. There's your x and y values. That is what you're doing on your homework tonight. Is it going to take time? Yes. It is not super difficult, but it will take time.
Can I take a picture?